Alright, so in this video, we're going to figure out, you're given a rod that is pivoted at this point, and we let go of this rod, so it's at rest at this point, and we drop it. And the question is, when the rod makes an angle theta with the vertical, with what speed is this point moving? Okay, the point on one end of the rod. Okay. So what I would like you to do is, again, stop at this point, think about what ideas you'll use, and then go ahead, solve the problem, and see what you end up getting. Okay, and then come back and or rather, once you get the answer or some answer you get, come back, check if it's all correct or not. Okay. So here's the approach we will use. I'm going to use the concept of the conservation of mechanical energy. Okay, so I'm going to use MEI equals MEF. Now, in the beginning, we realized that all we have is gravitational potential energy. Okay, now the common mistake people make is that they say that the potential energy is simply mgh, or whatever the height that you fall. But that would not be correct. Now the rod has length L, so the potential energy would not simply be mg times some length. Okay, what you need to realize is that because it's an extended object, the mass essentially is concentrated again at the center. As far as potential energy is concerned, that's what we're going to say. And you see it is this part that is dropping by a certain amount. So the change in this height here, is essentially what is going to give you your potential energy. And if you look at this thing, the length here is simply L over 2, and so this part is simply L over 2 times cosine of theta. So once again, the common mistake would be to write this as L cosine theta, and that would not be correct, because you see that there are certain parts of the rod that are falling a height less than L cosine theta, and then there are others that are falling a height greater than L cosine theta. And when you add all that up, you end up getting the change in the potential energy to be mg times L over 2 times cosine theta. And we know that all this is equal to 1/2 times I times omega square. Okay, but I itself is equal to 1/3 ml square times omega square. So I can simplify this and rewrite this as omega equal to 3g cosine of theta divided by L, and we have to take the square root of all that. Now once I know omega, we can calculate the velocity of the point P, and that is equal to omega times L, because the distance point P is from the axis is simply L, and so this ends up giving us 3g cosine theta divided by L, and I'm going to multiply this by L. But you see, I can move the L inside the radical, and that ends up giving me 3g cosine theta over L times L square, and then that cancels one of the L's. We end up getting 3gl times cosine of theta. Okay, so this would be the velocity of the point P. Now, this is at some random angle, some angle in between. Now, if the rod was vertical, then theta would be equal to 0. Okay, so at the vertical location, theta is simply equal to 0, and therefore that implies omega would be equal to 3g square root 3g over L, and therefore Vp would be equal to square root 3gl. Alright, so that's that.